Hello and welcome to helpyourmath.com. In this video, we're going to look at the terminology that we're going to see in mathematical expressions and equations. What's what and what? I find it helpful to know the terminology commonly associated with expressions and equations. We're going to go from the broadest to the smallest and everything in between. So first up, we have an equation itself. An equation is two expressions set equal to each other. So in order for something in math to be an equation, we need to see an equal sign. It could be something as basic as 2 plus 4 equals 6, or it could even be a little bit more complicated, such as 2 times x plus a half minus 4 times x plus 3 equals 6x minus 19. This entire thing would be an equation because we see the equal sign. So the thing on the left equals the thing on the right. And those things are not called things, they're called expressions. So expressions contain terms and operations. The terms could be variables, they could be numbers, they could be a combination of numbers and variables. They could be numbers, variables, and operations too. So many choices here. Generally, when we have an equation or even an inequality, this thing here we call the left-hand side, and this is one expression, one of the expressions, so the left-hand side. And this 6x minus 19 is the right-hand side. So we notice that the expressions themselves, the left-hand side itself, does not contain an equal sign. That's the expression. The expression doesn't contain the equal sign, but when it's equal to another expression, then it turns into an equation. Within the expression, and we're going to talk more in detail about each of these terms, well, we have a term which consists of the factors, and factors is going to come up real soon. We're just going to further break down expressions and equations to make sure we understand the difference between the two, and then we'll break down what's inside an expression. An expression is a mathematical statement that contains one or more terms. Soon we will talk about simplifying those. That's in another video. An equation is a mathematical sentence that has two expressions set equal to each other. On the previous slide, we saw the equation and then we saw the two expressions that made up that equation. We're going to look a little bit further at the parts of an expression. First up, we have a factor. A factor is something being multiplied to other things. If something is a factor of an expression, the only thing happening to it is multiplication. A factor could be a number, it could be a variable, or it could be an expression itself. So let's look at some examples of factors. In the term 7x, there are two visible factors, 7 and x, because the only thing happening to 7 is it's being multiplied to x. The only thing happening to x is it's being multiplied to 7. So we would say 7 and x are the factors, the visible factors. Every expression, every term, everything always has this invisible factor of 1, right? We could say there is also a 1 being multiplied there, but since the 1 is so common, we don't need to say it every single time. There's just always assumed to be a 1 being multiplied to any term. 1 is what we call the multiplicative identity, and we normally don't write it, although as you get deeper into algebra, sometimes you actually do want to pull out that 1, so that way you can actually physically see the 1. In another example, if we have 2n squared times n minus 8 in its current form, as we see it right here, there are 4 factors. And again, I'm calling them visible factors, the invisible one being the 1. We have a 2, an n, and an n, right? Because it's things being multiplied, so we actually need to split up the n's here. And then the other thing being multiplied is n minus 8. So this goes back to the fact that a factor can be an expression. We keep n minus 8 lumped together because remember, a factor, the only thing happening to it is it's being multiplied to other factors. We might also say, instead of writing n twice, which seems weird, we could say there are 2 factors of n. So whichever way, but it's the things being multiplied to each other are the factors. So we have a factor of 2, we have a factor of n, there's another n, and an n minus 8. And also, of course, a 1. Okay, so let's look at some examples. As always with all my videos, I always encourage you to pause the video, try it for yourself to see if you get what a factor is. What are we looking for exactly? All right, let's take a look. So in the first example, how many factors did you get in A? I heard it. I heard you say 3. That's right. There are 3 factors in A. We have a factor of 5, a factor of A, and a factor of B. In letter B, and this is where mathematics, I get mathematics can be confusing, and this is definitely one of those cases where it can be a little bit weird. So in letter B, how many factors did you get? I assume you said 4. I would say there are 5. And the reason for that is because that negative, does it necessarily belong to the 3 or not? We could say that the negative is its own factor, and if it's its own factor, then we have a factor of -1. We have another factor of 3, and then we have these 3 factors of x, or you could just say 3 factors of x. Now, arguably, you could also say that -3 is a factor and go with that there are only 4 factors. I think that's fair, but I think technically there would be 5 factors. The negative is not necessarily attached to the 3 the way it clearly appears to be. The negative is saying this term is negative. The 3x cubed is negative. So I think the negative is its own factor, in which case it would be -1. Again, that's a very technical thing. I think if you just said -3, you would also be fine. All right, letter C. How many factors did you get? In its current form, there are 2 factors. There are 2 things being multiplied to each other. There is the factor of 9, and there's the factor of w plus 6. If we were to distribute it, then it would be a different situation. But what we're looking at right now, there are 2 factors, 2 things being multiplied to each other. And in letter D, what'd you say? The answer is there is only 1 factor, 1 visible factor. The 5x minus 12 is the 1 factor that this expression has. If we were to break down and just look at the term 5x, that term has 2 factors, but the expression 5x minus 12 is exactly 1 visible factor. You could also say there's an invisible factor of 1. So this one, sorry, I'm supposed to list it, is 5x minus 12, and that's it. There's just 1 factor, 1 factor. Okay, so I've kind of been talking about this word term. We're going to go into a little more detail about what exactly a term is. A term is a part of an expression that contains factors. We usually think of it as being separated by addition or subtraction signs, but really it's just addition. If a term does come after subtraction, that means that that term is negative. It just keeps that sign that's in front of it. So examples of terms. We have this expression, 8m squared minus 19m plus 1/4. We see 3 visible terms. 8m squared is the first term, right? That's the first thing that's in between or in front of addition and subtraction. Then we have this one in the middle, the minus 19m, because we could rewrite it as plus negative 19m. So we have a term of negative 19m. And then we have this 1/4. So 3 terms. For addition and subtraction, when we're talking about terms, the invisible term is 0. So we could always say, well, you could put a plus 0 because that's not changing the expression. 0 is the additive identity. It's always present, whether we see it or not. Another example of visible terms in the expression -4 times x minus 3 minus 5 times x squared plus 6x minus 8. This has only 2 terms in its current form. The 2 terms, the things that are exclusively separated by addition and subtraction, are we have the minus 4 times x minus 3 and the minus 5 times x squared plus 6x minus 8. If we were to use the distributive property, that would change the number of terms that the expression has. And that's fine. It's just as it is now, there are 2 terms. But now let's talk about the numbers that we see in each of these terms. If a term contains a number and something else, a variable, a radical, something, the number is called the coefficient of the term. So in the previous example that we saw, 8 is the coefficient of 8m squared of that term, and negative 19 is the coefficient of negative 19m. And you might be saying, but wasn't there another number there? I remember it distinctly because there was a fraction, and you're right. But it doesn't have anything else, right? It's just that fraction. There's no variable, there's no radicand, it's just the fraction by itself. When we see that, that's called a constant. So a number that isn't being multiplied to a variable or a radical or anything else, just a number all by itself, is called a constant. And notice again, the coefficients and constants take the sign of whatever the operation is. So if it comes after a plus sign, the coefficient or constant is positive. If it comes after subtraction, then it's negative. And then just, one more thing that sometimes we might get confused about, if we just see a term that's a variable like x or a squared b, that would have a coefficient of 1. That's that multiplicative identity, that there's always something being multiplied to x and there's always a 1 being multiplied to x. If we see a minus x, it has a coefficient of -1. Okay, so let's break all this vocabulary down. Okay, starting with, in the expression 2x squared, the factors are, so how many factors are there? That's right, there are 3 factors. We have a 2, an x, and an x. In the expression 2x squared minus 9x plus 14, the terms, this one has 3 terms, and the first term is 2x squared. The next term is minus 9x, and the last term is 14. In this expression, the coefficients are, well, we have a coefficient in this term of 2, and we have a coefficient in this term of -9. And the constant, that number that isn't being multiplied to a variable or anything else, is 14. And the factors. Okay, the factors or factor, as it currently stands, there is 1 factor. In this expression, the entire thing is a factor. So the only factor, there's 1 factor of 2x squared minus 9x plus 14. If you want to say there are 2 because there's another factor of 1, you can also say that. That would be pretty rare to do. So that's why, sometimes I say like the visible factor, just because this is the one we see, and then 1 is the invisible factor. All right, so I'm going to take these up a notch. Always, I encourage you to pause the video and see if you can do these. Okay, hopefully you paused it. Let's see how you did. In the expression, we have x plus 3 times x minus 6. The factors are, this one has 2 factors, 2 things that are exclusively being multiplied. X plus 3 is the first factor, and x minus 6 is the second factor. In the expression, now we have 6 times x plus 3 minus 9x times x plus 4. The terms, this has 2 terms right now. The first term is 6 times x plus 3, and the second term is minus 9x times x plus 4. And again, if you use the distributive property, that's going to increase the number of terms to start, and then as we go to simplify, it will bring the number back down. But right now, what we're looking at is 2 terms. In this expression, the coefficient, so each term, if there's a variable or parentheses or a radical, then it has a coefficient, and the coefficient would just be that number. So we have a coefficient of 6, and here we have a coefficient of -9. In the expression 7x to the 6th minus 2x, the constant, so what's the number that's not being added, in the expression 7x to the 6th minus 2x, the constant, all right, so what's the number that's being added or subtracted with no variable being multiplied to it? I don't see one, so it's that additive identity. The constant is 0. That's not to say there isn't one. There is a constant. That number is 0. A very important distinction between there not being one and one existing. 0 does exist, it is a number, and that is also the constant. Okay, in the expression 3x plus 2, the factor, there's 1 factor, 3x plus 2. And lastly, the expressions of this equation. So going all the way back to the beginning, circling back, we have 2 expressions. The left-hand side, which sometimes I abbreviate to LHS, is 3x plus 2, so that's one of the 2 expressions. The right-hand side is going to be x plus 3 times x minus 6 minus 9. This has been a review of the vocabulary we would see with mathematical expressions and equations. Thank you for stopping by.